When running reactions in the organic chemistry lab, you want to have a way to monitor them. One of those methods is known as thin layer chromatography, or TLC for short. This works like all other kinds of chromatography in that you have a mobile phase and a stationary phase, and the compounds that you're trying to separate interact with these two phases. First, let's talk about the stationary phase. In TLC, you usually have a plate that's completely coated with silica gel. The silica gel is the stationary phase. There are other materials you could use, but silica gel is the most common. What you would do first is take a spotter and dip it into your reaction flask, then put a little spot here. You want to find out whether is there one compound in there or are there multiple compounds. Next, what you'll need is to prepare the mobile phase. This is done in something known as the developing chamber, shown here in white. First, what you would do is put in a tiny bit of your mobile phase, meaning it can be any solvent or any mixture of solvents, and you want to keep this to be a relatively small amount. If the level of this is too high, your spot will be completely submerged in this. You'll want to put in a piece of paper that will indicate whether or not this chamber is saturated. When setting this up, you want to check that this piece of paper is wet. This lets you know that the vapors from the mobile phase are completely everywhere in the developing chamber. Next, what you do is you take your TLC plate and put it inside here. Finally, you would close the top. You want to do this because if you didn't and you left the top open, organic solvents are very volatile, meaning that they readily evaporate from liquid into gas. Next, what would you observe? Well, let's think about what could happen. You have your pink mobile phase, and what will happen next is that it'll travel up the TLC plate through capillary action. Capillary action is just a term for when you have some kind of solid thing, like silica gel, that sucks up a liquid. And when you see that it's gotten pretty close to the edge, say around here, you'll want to pull this out of the developing chamber. Make sure to use a pencil to mark where your mobile phase got up to. How come we can't see anything yet? That's because usually you need something like a UV lamp shining on this so that you can visualize something. So let's say we take our UV lamp and shine it on here. Compounds that are aromatic will usually show up and fluoresce. And let's say that we had these two dots. So what does that tell us? That tells us that whatever was in our reaction flask was a two-component mixture and that there's at least two compounds in there. However, you would have seen more dots if there were 3 compounds or 4 compounds or even more. TLC plates can get really messy when you're doing research. But what can we tell about these two compounds? So TLC is a pretty qualitative method. It'll tell us whether things are more polar or less polar. So what we have to keep in mind is that the stationary phase, or the silica gel is very, very polar. So you can see this one didn't move too far. Means it must have been really attracted to the silica gel. But this one moved a lot more. So this is less polar and more attracted to the mobile phase. Okay, so we still don't really know what compounds these are exactly. But let's say that you knew that inside the flask you had naphthalene and benzoic acid. How can we tell which spots these correspond to? Well, you'd want to look at them and figure out which one is more polar and which one is less polar. As you can see, naphthalene is just made out of carbons and hydrogens, so it's pretty nonpolar. So we can indicate that this corresponds with this, and because of the carboxyl group in the benzoic acid, this group right here, you can tell that it's a pretty polar molecule. So this would correspond to this. And that's how you do a TLC in a lab. Again, let's review. You first have your plate that you put a little spot on. You put it into the developing chamber, which contains the mobile phase. Wait a little bit for the mobile phase to travel upwards. Pull it out of the chamber, and then use a UV lamp to see what spots are there, and then try to compare those two spots in terms of polarity.